Hello, 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 welcome, welcome, welcome. Yeah, let's get into it, I guess. Did a little bit of render dog debugging on Windows, so I know what finally is happening here. So let's do a couple of things actually. Let's add a new function here. Basically void set data, and we template that. Where we do a t here, and either it is a dynamic array of t, or actually we could probably do a span of t. Let's try that. Data. And then basically we do buffer, set data, get offset. This is the issue that we had yesterday. We didn't offset it properly into the buffer, so we overrode the sphere buffer because we are in like one continuous buffer range basically. And then we do data here, like span. And then we do span dot size times size of t. What is no? Okay, so that should do it. And then let's add another overload here just in case, where oops, jeez, that's not what I wanted. Where we take a t reference here. At least I think that should work. Alright, we need to take the address here for this to work. And then the idea would be that instead of doing that, we can just do this, right? And we don't need this offset here anymore. This is enough. And that should already fix the issue that we had yesterday. Because now we properly set the data with the correct offset here, right? So that should fix one issue that we had. Not sure if it will fix everything right away, because I think the shader is not correct yet. But we'll fix that in a second. Then the question is, I wanted to look at the rotor. Do I have a matrix 3 here? Yeah, I do. Oh, that's perfect, probably. Okay. Good to know. Alright. So in theory, if I add a box collider here now, that should hopefully appear-ish. Well, it kinda is here, but it was barely, it's hard to see, I think. Or it was briefly here, but yeah, but the sphere works again. And then we can fix the... Okay, why did that not fix it? Or did I debug draw sphere? Did I for some reason still have it commented out? No, I don't. That should have fixed that. Huh? Oh. DI. Is it not DI? I thought it would be. Oh, okay, it's that. Huh? Okay, thank you. What is alias? It's 1. Offset 320. That looks correct. Isn't that correct? So a debug sphere is how big? 20. 320 sounds correct. .24 length. That looks a little... No, I mean, maybe that's correct. Actually, that might be correct. Oh, but why is it in this overload? Ah, because we're not a span. That's why. Does that work? Yeah, I think it does. That's why I need to convert it to a span. Or not probably, that should have... I mean, maybe it's not exactly the same, right? Might not be exactly what it should be. Oh, shoot. Yeah. Okay. Let's add a sphere collider here. Perfect. Let's add a box collider here. And now we crash. Oh no. And now we are not overriding this here, so that's already a good sign. But yeah, we're not rendering it, but that's fine because I think the shader is not correct yet. But at least the sphere works again, right? So, hey. So very sour. Hello. Okay. So let's fix the shader, I guess. So let's go to our debug sphere shader. So the first thing I want to add, which makes it a little bit bigger, but it's fine. Do I need that? Yeah, I mean, let's... How much bigger is it? I'm not sure yet, but... We basically need... Do I need the rotation? Yeah, I do need the rotation. We need the same in the debug shapes. So this is currently 28 bytes, right? And then if I add a matrix 3, F32 would be the idea. We probably need to define that. Okay. Maybe I want a matrix 3x3 though, to be explicit. And that is a matrix 4x4, I think. Right? Yeah. Because maybe we want to have a different type in the future. For like a 4x3 matrix, for example. And then this is 64, which makes sense because it's a 3, 4, 7, 8, yeah. That makes actually kind of sense. Okay. And then what I need to do is change this here a little bit. So we get the box. Not sure why I did that, but okay. Now we need to offset our array here. Well, I guess we could do it there. So basically what I need to do is my array origin vec3 local like ray origin box space is our box dot rotation times the array origin minus the box position, I think. Kinda do similar thing. So basically the vec3 ray direction box space is our box rotation times our ray direction. Pretty sure that's about it, what it should be. Well, not quite, but yeah. We actually need mat3 inverse, or like word to box space as our box rotation, but we need to transpose it. So basically that's the inverse, but as we are just a rotation matrix, that's totally fine to do like that. Word to box space, and then we take that, paste that here, and then this is our ray direction in box space. That is our ray origin box space. That is our half extents. Like that. Now I do all of that, that's fine. We could do a couple of helpers here. Well, nice parentheses, I guess, here. Like structure this a little bit. And then I want to hit normals as well here. So basically not only one, but we need like two. So basically this is the hit normal. Entry. Which actually is not quite that. It's just this tn like 1 and then times our minus sign of the ray, well, of the local ray direction. That is like the entry one. And hit normal exit as this one. T2 vec3 that. And then as well, I mean, I guess we could cache that vec3 ray signs. Now we return hit T and that's about it. And we could actually return here a vec2. Because why not? We return here vec -1. And here we return that. Now we go here, delete the outback. Alright, so then with that in place, let's go to our box intersection. Have vec2 hits here. Get rid of that. Vec3 hit normal entry. Hit normal exit. Okay. And then basically what we do is if we hit, so basically if hits at I think actually it should be is it hits? I mean maybe. Then it's like that basically. At that point maybe that doesn't even hit, right? Let's see. Let's do that. And then for the get wire thickness, what I need is technically just the I think just the half extends. Oh, but okay, well, okay, that's I need something more basically. Actually, I need this. I need that here. Ray, origin, box space. Ah, that's interesting. Okay. Okay. Okay, and then get wire thickness. What we do is we get the local hit position, or we can reconstruct that, right? But now let's give it the box, give it the ray origin, box space, ray direction, box space. Give it the hit T. And the hit normal entry. And that is as well in box space. Okay, yeah. Ray origin, box space, ray direction, box space. Okay, so that should do it, and then what we need to do is here hit normal, exactly. And that one is like a little bit simpler now. So basically we do vec3 UV. Technically that could be just yeah, but whatever. Hit, where the hit position is vec3, hit pos is our ray origin plus our ray direction times the hit T. And then this is hit pos divided by our box half extents. And then we have the vec2 phase UV, which is basically the same similar thing that we had before. So we do abs of the hit normal, which is in local space now, bigger than 0.5 f. Then we say phase UV is our UV YZ. YX, I think. XY. And then edge distance is again this change with the UV, phase UV here. I'm blind. And then, yeah, this is still the same. And then the wire thickness is basically that times 2. Because why not? Because I think we do the same. Well, here we actually do it a little bit different. I think we want times 2 here as well. But then again, why would I do that? Yeah, whatever. That's oh shit. Let's keep it like that for now. And then this is as well the hit normal with the ray direction. I think that should be correct. It's just that we need to add the rotation. So in the debug draw Q, yeah, here we do a matrix 3 by 3, basically identity. Is that an identity matrix? I think, right? Yeah. And that should do it for now. I probably did a mistake with the shader, as usual. Probably did a mistake in the shader somewhere. As usual, because I always do that. Yeah, I'm not sure. Is that even hit? Probably not, right? Well, actually, if we are inside, it might be, right? Well, whatever. Let's find out. Did I crash? Of course I did. Hit normal box space entry. Okay. Oh, where the exit? Oh, okay. Well, that was unfortunate. Did I save? Or I saved now? But of course I still have a failure. Oh, where? I can't type, I guess. Half extends. What? What? No. Well, let's see. Hey, GD Bobby. Hi. Okay, I don't have any errors. That's a good sign. Let's see if the sphere still works. That one works. Perfect. Let's see if the box works. Where? Oh, actually it does. It does. It's just very thin. Perfect. I think I know why it's that thin. But I think what we will do is we will get rid of that and just turn up the wire thickness. So let's add a sphere here. Make that 100, perfect. Add a box here. Make that as well. Well, let's make it 40 because it's half extends, right? Perfect. I mean, I guess the box could be a little nicer. And there's a weird artifact here, which I'm not quite sure where it's coming from. Like here is an artifact. Not sure if you can see it on stream. But we'll deal with that later. Overall, not too shabby. Okay. Or we have boxes and we have spheres. That's almost everything I wanted. And we can move it, right? And in theory, I think, well, currently it doesn't. But in theory, it supports now rotation, so I could rotate it. And it's in the center, but I still don't like this. I'm not sure where that's coming from. It's somewhere in the scene editor with the IM gizmo, but I'm not sure what I need to do to fix that. We probably won't do that today. So I think I will do some other stuff. Well, I will clean up that and then we submit that and then we go to the ECS and then we are basically good to go to move towards adding physics to the terrain. I just wanted to see quickly if there is something I can do. If I spot something that's off. So I give it this. I am gizmo local. Maybe I need to do I am gizmo word. But I doubt that this makes a difference. It's probably something else that causes this weird offset. I'd assume. Did I actually save? Well, let's do a box collider, I guess. What did I want to test now? I have the gizmo, but no, the gizmo is still weird. I don't know why it does that. What else do I have here? I guess not a lot. I would want this to be different, but yeah. I'm not sure. I would need to read up how Gizmo works. If there is something I can do to change how the gizmo is positioned. Because I would want it to always be in the center of the object. But it just isn't. Oh well. Let's do things first. So one thing I wanted to try is, so currently, oops, let's close that. Not close that. So how do I want to do that? Oh yeah, I wanted to actually store the debug queue in there. Isn't that debug raw queue? Wireframe spheres. Isn't that how it's supposed to be? I just can't type, I guess. Include Onyx graphics debug draw queue. Thank you. Actually then this one would just be let's do a lowercase, why not? Let's start doing that. Follow the C++ guideline more or less. Oh well, this one then would be friend plus debug draw task. Is it not debug draw task? Wireframe spheres. In that case, we could actually clean that all up. Wireframe spheres. Add wireframe box. We yank that, we add another one. Well, we take a matrix 3x3 as a parameter here. I think I want to add an identity here. Well, okay, I guess. Isn't it? Wait. Its position? Yeah, shouldn't that be fine? What is the problem? Oh, no, that's fine. Well, let's see, I don't know what the problem here is. Its position? Color, rotation, half extents. That's exactly how it should be, right? Yeah. Oh, but I guess we have a weird error again. Yeah, this doesn't work somehow, and I'm not quite sure why it never works. Oh wait, is it because I need to mark this as const export? No, I guess not. Yeah, I'm not sure. I need to still figure that one out. It would be nice if that works, but it somehow never works. So I guess we need to do it manually. Okay. And then the idea would be here that when we draw here, that is a debug draw add wireframe sphere. Add wireframe box. But we give it as well the transform rotation get or 2 matrix 3. Oh wait, it's not like that, right? It's here. And that should be it. This one needs to be a ref. Game core. I still need to find a better way how to define those, because I preferably would want to define that somewhere else. But it's fine for now. That's oh, delete that. That should hopefully still work then. Well, oh, never mind, I didn't adjust the debug draw task, I think. Yeah, I didn't. Why is that not working? Shouldn't that work? Debug draw. Class debug draw task. Oh, because render graph nodes. Does that not work? Does that not work? Well, I get. Yeah, no, I'm not sure. Well, let's not do it as a friend class, it's fine. Const dynamic array get wireframe spheres. That should work, and then this one is at wireframe spheres. Well, I guess. Why would that not work? But okay. Actually, let's actually a const span maybe. Why would that not work? Shouldn't that? Why would that not work? But now it should work. Oh, Isn't STD span already a thing? Could I not just do that? I think I will just do that. Let's kill this span. And go here. Kill span here. Go to common.h. Onyx types, never mind. Here. Then we need to go to onyx.h and include span here. And I think that should hopefully work. Where else do we have span errors? Image file? Ah. What is the problem? Oh, here. Why is this a thing here? The thing is, I think that's now more correct. The span that I had was a really bare minimum implementation. So that should be a little bit better anyways. Clear the output. I don't know why it still doesn't do that, but yeah. Where is my error? Oh, here. Okay. Shouldn't that work? Do I need to make this const as well? No, right? Doesn't std span support the const version? Isn't std span supposed to be able to do that? Why is that blocked? Wait, did I just press the wrong thing and it deleted the... I'm so sorry. I don't know why the automod flagged the thing and then I pressed the wrong thing, I think. Can you post it again? I'm sorry. I'm not even sure how I would get it back. God damn it. And now it didn't even flag it. Do you also have the thing where you start speaking in native language? Maybe, yeah. Probably. std span const t? Ah, you mean span const? I mean, maybe I need to have here. Very bizarre. Is there no version for span that's taking a const? No, I don't want span of const t. I want a... Or actually, I guess it doesn't really matter, but... No, I just want a span on the array, but can I not mark that const then, or what? No, that doesn't work either. Why would that not work? I mean, that probably is garbage. But for some reason, just doesn't like that. No, not quite sure why. But it's not because where it's called, right? Let's actually do... Just to be sure, let's change that to auto. Here. Oh, okay, now it works. So it was actually... But that still doesn't work, or what? Oh, okay, it works like that. Okay, cool. Then that is fine for me. Debug box. Oh. Shouldn't that be exactly what it should be now? Right? I love intelligence that it was like underlining it, but it seems like it's fine. I don't know. Yeah. Okay, so that's fine. We have some other errors now. Not quite sure where, but we will figure it out. Yeah, I can't somehow look. Oh, where? Maybe. Okay. Cool. That is the only thing that I get as an error. Cool. Oh. Yeah, okay. Sorry. That was actually quite clear. I'm mostly reordering them to be alphabetically. Doesn't really matter. Okay, cool. So I think that should now work. And it should still hopefully work everything as before. in sense of that we still have a debug box and a debug sphere and everything is nice and dandy here. And then maybe I will add one more shape and then we will go to the ECS system. And then we will call it a day. Or do I even do the other shape? I'm not sure, let's see. But it's not really needed right now. We can add it later as well. So we have the sphere here, perfect, and then let's add the box. And in theory, this box now should as well support rotating or not. God damn it. I thought, where? I should have done that. It should have worked. Or maybe... maybe my rotation stuff doesn't work? Okay, well, it doesn't work, yeah. Did I not? Oh wait, maybe I'm not actually... Am I not adjusting that? Transform. Maybe I'm not actually... Wait a second. Am I not doing... Oh, maybe I'm not. Okay. I think I need to add a factory here. And change that to a transform component. Before doing that, what we will do is transform rotation as isn't that what I wanted to do? Probably not. Transform. Or maybe I wanted to do that. Yeah, like that, basically. Alright. Was it transform? No. It was word transform, okay. Not Onyx graphics, Onyx game core, components, transform. Isn't that it? Well, actually, we can, I think, do that. Question is, do I want to do it like that? Maybe I want to do it slightly different in the long term, but let's see. Should at least hopefully give us now that the transform actually gets reapplied. Basically, I can do 40, 40, 40 here. And then if I rotate that by 45 exactly, now we have we can do that another 45, and we have like aligned, like well, non-axis aligned bounding boxes as well, in theory. Which is quite nice. Perfect. We don't need to do that for the sphere, of course, because the sphere is always the same, right? You cannot rotate that anyways. Cool. I think I will submit that, or do we add the other shape? No, I think I will go to the entity system. Let's do first this and this plus this, which I think, well, and then this and I think those were the only ones that were important. Yeah. Removed, custom, span, replaced. Because we don't support anyways anything lower than C++20 anymore anyways, so and we keep that. I think I don't need to submit that. Yeah, that we will keep. This one is definitely an improvement. Yeah, let's keep that plus that. Don't need that. Edit using layers for okay. Let's do that. All right, debug. Why we probably should rename this shader. Debug draw. Okay. And then that's basically that. Oh shit, I forgot this, but that's not too important. That one is not needed. Yeah, that one is, let's push that. Plus those. Okay. Added wireframe debug rendering. Cool. All right. Then we can go to. So we close all, I guess. And we go for sure to entity component system, I guess. And now we basically, if we go to volume terrain system, so if people didn't follow last time, so what we will do now is currently I define entity accesses for my entity component systems, as you can see here highlighted. So we have like read accesses with a const keyword and then the component, and read accesses are without the const, of course, but there is as well certain components that we don't really read from, but they are still here. I mean, in theory it could be const, but even then this doesn't really change anything because we are never really reading or writing from that. We just are interested in that it has the component. So basically the new access pattern will be something like that, where we say we want to access terrain or like entities, we want to read from a certain component, we want to write to certain components, and we don't need the const anymore. It's basically within this type info here, like within this type. And then we can as well limit it based on like a with or without flag, basically like marking components that we are not reading or writing, but that we just need to guarantee that the entity has for the system to run. So for the terrain entity read, this doesn't really make sense with the enemy faction at that, but that was just an example, right? And as well, the syntax will support that we can do all of them in one. If you want, you don't have to, but basically it would be the same as doing this. Which I think would make it quite easy to understand, read, and everything. So that's the plan. Let me quickly open a couple of notes that I have for that. All right. Good. So we will start. We kind of need to rewrite a bunch of things here, but that's fine. It will be all for the beta. So basically we have a template, type name, component access definition, And then this is a struct entity query. We have the same thing, just with an entity. And yeah, this one will change. And then we have a struct access, where we basically define a couple of things. So first, enum class memory access. That is basically how we want to access a component in terms of memory. And that is either none, a read, or a write. It's nothing in between, it's just those three. And then let's add another one. And that is basically a filter. And that again, well, that has three values. It's include, exclude, or maybe, which will be resolved in a second. We'll see why we need a maybe. And then we start with a private struct here. Now we have a template type named T, memory access U, and a filter F. Now we have our component access definition. That is just a using T. Well, actually using type. Yeah, and then yeah, static const expr. Well, actually we could do it probably const eva. No, we need it at runtime potentially. This is a filter flag. Yeah, because I think it doesn't really like it that... Oh. No, I think it's fine, right? To have it like that. And then we have a struct access builder. Again with the template type name. That is now a expanding template. And we might move that into its own header. That might actually be a smart thing to do in the future, but yeah. We need a view here, well, a helper template. Well, actually that's not the helper template, but I mean kinda it is. T's, where we do a using read is an access builder. with our component access definitions and we expand them plus the new component access definition T's, and this one is a read. And this one is a filter include. And then we break them up. Now we do that again. Change that to right. And change that to right. And then we have a couple other. Not yet, no. That's on the long list of features. Long list of features. So those are read, write, and then both as an optional thing, because we might not want them, right? I mean, we might want to have a system that potentially wants to write things if it exists, but it doesn't necessarily is a hard constraint on the system. And then we need 2 more for now. Well, we probably will add a couple more, but well, actually we can copy. So then we have here the width, which is an access pattern of none, but we need to be included, right? And then we have without, which is as well access pattern none, but exclude. And because I am already at it, we add one more thing, and that might be a little bit confusing, but basically we add a has, and the has will be a none and a maybe. So this is a few, like this is a real exclusion filter, right? The width, it has to have that component, and without it isn't allowed to have it. And with this one, we're basically saying we want to check if it has it, but it's not necessarily a hard rule. Yeah, then we need a couple of helper here. So basically read components. We don't really need them yet, but it will be nice to have in the future. Oops. So we do a decker type of std tuple-cat. So basically we construct a list here where we do an std conditioner where our component access the component access definitions and the access is the memory access. How did I do that again? Man, I hate it. I did it again. I always press U by accident. Jesus. My fat fingers. Read. So that's the first constraint, but we need another one. And I think we want to have... Why do I need? Actually, no. I think that's the only constraint we want. Because there is no read exclude. So I think that's fine. Now we do std tuple of type name component access definitions type. And that's like a really insane, confusing macro, not macro, but what do you say? Jesus. Yeah, using statement or like whatever. I think at least that's correct. I'm not 100% sure it's correct, but I think it is. And then we kinda copy that. And we do the same with write. And I think that's mostly it. We don't need the other constraints for now. I think. Yeah, we don't. And then I have a using here again, where we do a query is an entity query. With our component access definitions are opened up. And we basically copy that, change that. And then we need another thing. And that one is a little bit confusing again. Actually, we might do entity registry. Is that even a thing? No, right? Basically, it's this. Kinda. The list is a little bit different, but basically it's this. What we already have. It's just that we do for storage T, where we break up our component accesses. And then we don't exclude anything for now, but basically we would need to exclude something here. But yeah, let's deal with that later. And then we have a public section here where, because that is like inside the access builder, right? And then we basically copy paste those. And have them here. And we do that mostly so that it's a little bit encapsulated. And then this is a component access definition. Like that. At least I think that was it. I'm writing it a little bit, well, with some notes, but a little bit from memory as well. So I think that should give us now that we have using test access is entity access read game, or actually, yeah, read const, or we don't need const, game core transform component. And then that one, well, that is just the access, right? And then we would do a using test entity is an entity of test access. That would be the idea. Something along those lines, I think. So this one needs to change. Component access definitions. Actually, I think we might not need that, sorry. Maybe we don't need those two, but I'm not sure. Because we will do another thing here where we basically do using included components. Is a decker type. Now we do another std where we can probably kind of copy that from here. Let's do included components, I guess. This is basically everything where our filter is access filter included, or include, sorry. At least I think that's it, and then we have another list where we do the same thing, just with excluded. And then the Qt is a little bit different, so I need a couple of helpers here. At least I think I need them. Maybe there is a better way, but for now we will do it like that. So basically we get a template of type name Now we get a const expr or static auto make view type, and we get an std tupper. And basically, well, yeah, it's basically that, right? Yeah. And then here we return an end basic view or something similar to this. And then maybe I don't even need that, right? But yeah. Return this with all the included, but we need to get the proper type here. So we need to break that up a little bit here. So we get the storage 4, but then here this needs to be a sub car where we do std conditioner based on the included access, and if the access, I did it again. Right. Then we will do type name included type. Otherwise we do, oh yeah, makes sense. Otherwise we do type name, because if we write, then we are basically like that. Otherwise we are a const type name included type. Now we close that, we break those up into individual pieces, and that's about it. And we get rid of this, and then we have an end exclusion list here. Let's actually do it like that. And then the exclusion list, that one is kind of simple. It's just type name of the excluded type. And then we break those up as well. Yeah. And then the view T is basically that. So basically we change that to a decker type of make view type. Yeah. And then all we need to do is a couple more things. So we get the registry, that's fine. And isn't it just get view? Of view T, I think. Well, otherwise it could be hold on, is get view entity registry? How does that work? The get view. Oh, the excludes is a list. I guess in that case we could do like that for the inclusion list, right? Is that correct? And then here we do that. Alright, let's keep it how I have it in my notes for now. So we get a private function here. Where we have, again, probably doesn't need to be static, but whatever. Alright, let's not make it static then. Alright, I mean, whatever. So that part I'm not sure. I think there is an optimization here where we can do a little bit less of template stuff. But yeah. Basically here we return a registry get view with our... So that's the weird thing, why I'm not sure why I did it like that, but it's basically this line again. Just a little bit confusing. And I do think I would need to write the excluded here. For it to actually work. I think something like that. This one would be make view with our registry and our included components and our excluded components. And that's why I'm not quite sure if I even need this. But yeah. Yeah, we don't need that. We then don't need that. Have the registry here, that's all fine. Okay, now the entity is very similar. Component access definitions. It's pretty much a copy. So basically here entity query of component access definitions. And we actually get an entity registry here. No, actually, we probably don't. Query entity ID, perfect. And that pretty much stays the same. The try get component. For now, let's return a null pointer, because I'm not quite sure about that one. And then this is component access definitions. That's the query, that's the entity, perfect. So I think that's mostly the biggest changes. I'm not sure if it works right away, but we will try. But first I will take a quick break, get some more water, and yeah, water and bathroom break. Be right back. Alright. So it probably will horribly fail left, right, and center. But what we will do is we will copy, we not copy. We will comment those out for now, and we will go to other systems. Huh? Why is that not working? Okay, and then I would want to find all of those references. Well, that didn't work. I guess that didn't work. Okay, great. Let's see. Exactly, let's actually go and disable the lighting systems as well. Is my did my language server die or what happened? It feels like it did. Oh yeah, that looks already better again. So let's well, the camera will leave. The camera system will be the first one we will revive. Camera and then volume. Okay. Good. So then we go to the camera system and let's fix it. So the thing would be that we do an entity, well, camera entity, I guess. Oh, that one is actually quite old because, yeah. Entity access. And then we want to read a transform. And we want to write the camera component. And basically the camera entity then would be an entity on the camera access entity. Not quite, right? Is it like that? Somewhere there is a template missing, I think. Oh wait, I don't need that. Wait. Oh, it's like that. Jeez. Just I mistyped everything here. Let's for now leave out that. But is that even correct? I think there's one too much here. The one too much here. Cool. Guess we could do this. This. Good. Anything else while here as well? One too much, one too little. This, probably this. Missing. Oh, we're here. Okay. That, and then there is one more here, types. That is, of course, component access definitions. Well, actually, it's probably not that. But whatever. It's probably not that. It's actually... Well, what we will do that later. Let's first try to get one up and running again. I don't think this will work, but yeah. Camera entity. So that would be the idea behind this. But of course, that doesn't quite work yet. So I think what I need is in access. I actually need those outside here for now, but there probably is a better way to do that. Is that not it? Oh, maybe not. I thought I did that like that, but maybe I didn't. Oh no, but actually, yeah, that makes sense. Actually, I think I can do a here entity. I think. No, this is a transform, this is a camera, but seems like that doesn't really work. Yet. Is that not it? Or maybe not, right? Maybe I need to refine that a little bit. And we wanted to refine that anyway, so might as well do it now. So I think what I need to do is, yeah, we have the stacker type auto, which is basically the tuple accessor. And we need a tuple accessor, a correct one here. So basically we do std size ti, and then we delete this and we add a little bit more stuff here. So basically definition, or like component access definition is an std tuple element at I of our how do I call them? Access. It's not only included, right? Or is it? I mean, technically, maybe it is only included, right? So I want to return this. Maybe accessed component definitions? I don't know. Or like where, I don't know, maybe we actually do it like as a type here. Or it doesn't really help, right? I still need a name. Memory access components included memory access components. Let's name it that. I don't know. Decker type. And we do a pretty much a very similar thing to this ish. Well, kinda. Basically, our filter is include. Let's do that again like that, so that we have the condition in like one line and then the rest in the other. So it's filter is I guess not exclude maybe. Well, actually no, we only want include here. Yank around that. Well, Jesus. And now we paste that. And so the filter is that, and our memory access is not none, I guess. And then we basically return this list again. Oops. That is going in here. At least I think. Well, actually tuple element t because I want the type. And then if well, actually nothing if we return, or we need the raw type basically, sorry. Well, another one. So if our component access definition memory access is right, then we return component access definition type. Otherwise, we do a const version of that. Isn't that the thing? Oh, need here a colon. Okay. And with that out of the way, then we can basically return an M query, get view, template, get T. And I mean, that is more or less it. ish. But let's see if we have it now. So I think we need here 0, and then this would be because we don't have the full tuple access yet. Isn't that how it should work? Oh, where? That's not how I would have wanted it, but fine. Okay, so that works now, right? Yeah, that is a const transform component. So we're almost there. It's not exactly how I would want it, right? But basically we can now do this, and this is an auto camera here. And that works, right? So that's kinda working. Now we need one helper more, like one more helper, and then our entity component system is beautiful. So we go back to our entity component system and go all the way down, because we need to do that in the std namespace for a tuple access, so we need that, right? And we need the template type name component access definitions struct tuple size of Onyx entity yeah, and then entity, and then component access definitions, this broken up, then we close all of that. That's like a tuple access, so basically it's like really, like I really needed a couple of attempts to get that right, but yeah, luckily I have a couple of nodes already. Oh well, and then this is our, yeah, that is our included memory access components, which we need to expose actually. And that's about it, I think. Oh, we close that. And then we need another one. I mean, maybe I copy, I don't know. It's not quite the same. But a little bit similar. That is tuple element and we don't have that, but here using component access definition is the type name of our Onyx, or basically this one here. Oops, yank, tear that, I guess. Well, that's not what I wanted. Ah, it's fine. That, and then where this, and then template that. I think something like that. Oh wait, actually, yeah, that's not quite correct. We don't have that yet, but it's fine. And then we kind of do the same that we do in the in the getter. Well, actually, can't I just do? Oh, maybe not. I don't know. But yeah, basically we do the same thing that we do up here somewhere already in our declar auto. Here, this one. I mean, I guess I could do that, right? Or whatever. Or it would be this. And we need to do that as type. Then yeah, we need to go up here, take that, actually do that outside here so that it's accessible. I don't know, or like tuple accessible components maybe? I don't know. It's, I guess, fine. And I think that's mostly it. We need one more using, or not necessarily actually. So let's paste that here. Hello, what's up? And then this would be std tuple element t add I and this included memory components. But I'm not quite sure why would that not work. Ah. So that, and then this is a component access, I guess. Almost, and then this is Onyx entity access like that. And I think with that, we're done. Hopefully. So now we should be able to go back to our camera system. So we can still do that, but I think we can now do the other approach again. And just do it like this. Or maybe not. Or maybe. Let's see what gets spit out. Where? Unfortunate. Not quite there yet, I guess. Oh, okay, well, probably we need to... Maybe I need to just comment all of them. Probably some others now that fail. Oh yeah, well, the free camera system we as well still need to do. So that would be camera access again, which would be an entity access read on the free camera. And then a write on the transform and the free camera thing, and then we use camera entity Yeah, it's probably somewhere that I still do something wrong, but let's find out. What? Use of undeclared identifier get. But it doesn't really, yeah, it doesn't really specify anything. But let's see, let's get rid of that, I guess. We will add all of them back once it works again. But I first need to get rid of all the other errors so that I can fix the one that is blocking it currently. That might now be already the case. Okay, no lighting system, yeah. Okay, good. So that is this error. Do we have anything else? And we have this as well. And that's it. Okay, good. So what the hell is going on? So let's see. And of get. What? Oh wait. Do I even call it get? Because I think for a tuple accessor, yeah, exactly. This needs to be lowercase. Wait, not this one. Where's my entity query? For the entity query, yeah, here it was. This one needs to be lowercase for this whole template magic to work. Okay, that looks better because now it at least goes further down into the template chain. So we need to do... Where is that? Ah, we have another like volume terrain system, okay. Any other system? I don't know. Maybe not. Okay. No, we do have another system. Jeez, why do I have so many systems already? It's not what I wanted. No, just kidding. It's pretty nice already. I think that looks good. I think we might be onto something here. Okay. I think we're starting. Mo system, Mo problem? What? Well, what? Is that? Why would this fail? Eh? That doesn't make any sense. Why would my shader compilation fail? What? What the hell? Which graph node are you? I don't see it, or what? Well, that is unfortunate. What? Node ID 13. That's pretty much at the end, or? That is the last one, yeah. Is it something with the debug draw? Did I break my debug draw somehow? But it was working before, right? Was it not? Debug draw, oh shader. Did I not name it like that? I mean, that looks fine. Why would that fail? What the hell? Okay, interesting. Oh no, wait, we failed when we entered the scene editor, right? Yeah. Still not quite sure why. Missing asset. Is my shader not there or what? That's the weirdest thing ever. Because shouldn't that just work? It's actually where is that? What are you trying to load? Trying to load a shader, yeah. We're trying to load don't know what. That would be so nice if I have a name here, but for some reason I stripped that away. Not quite sure why I did that, but yeah. I guess it is. But why would that be missing? Asset list. I mean, it will be hard to find. Debug draw. And isn't that the asset ID? It's not. What is the asset ID? The resizing in the render graph. Let me think actually. I think currently it's a little bit scuffed, but in theory it's there. Is it in render? Probably it's in render graph. Actually, I don't think I'm handling it anymore since Wayland. I think with Wayland I killed the resize for the render graph. But there was here the on swap chain resize, and then every node gets that call and adjusts its resources. That was the idea, but I think that is killed currently. Because I don't think this is called. Yeah. But that was the idea. So basically I get the on swap chain resize, and then we resize swap chain sized resources. But since Wayland, that's dead. Okay. Is that a shader asset ID? Yeah, it is. I want to see if that is the same. So basically I'm looking for this one, right? Okay, so it's not this one. Which one is failing then? What did I break? Oh no, here. Why is there a shader here? Let's kill that actually. Oh, that is it, I think. Man, that's so stupid of me. Because it was saved with the old name into the file. Yes. That one should disappear. That's the wrong one. Default render graph, and then we go back here. And I think all of the fixed ones should actually not have that. But I'm not sure. I think I will remove the serialization. Yeah, that makes the most sense, I think. Render graph task. Fixed one. But where do we serialize that one is the question here. I think this one needs to die. Well, the deserialize not, but well, actually both of them need to die, or? I will think about that, but I do think those two are a bit scuffed. But yeah, that's basically it. We were saving it with debug draw sphere, I think, right? And now it's not called debug draw sphere anymore. Well, yeah. I should have maybe tested that before submitting that, but I think that should work. Okay. Well, kinda. Did I not? What the hell is going on? It's still in a shader, it's still in the create shader instance, it's still... in the node ID 13. Still the last one. So still basically... But why is it now fail? Now the shader asset ID is 0. How the hell did that happen? Hold on, what? What am I doing there? Render graph task. Oh wait, read optional. Does that always return true? No. Oh, but it returns true even if it's not there. That's a problem. Well, I guess we could do shader. Well, pipeline properties. Jesus. Does that not as well support default value? No, maybe not. Yeah, that's fine. I guess we do it like that, and then we fall back to the correct value. Funky. Should rethink that probably. Slightly. Yeah, okay. Good. And we can still move the camera, so that works. So the camera system works. So let's do the rest. Thank you for the follow, X Lucao Gamer. Thank you, thank you. All right, let's fix the other systems. So let's go back to the camera system. So yeah, that would be the idea. Maybe first of all, we definitely want to do it like that. And that. And then probably that's fine, right? Actually, I will rename this. Like that. Yeah, it was something stupid. I was not... I didn't initialize the shader here as the default value that gets set in potentially a constructor, so I needed to add like this part here so that it sets it to whatever the constructor set. And then I don't even think I should serialize and deserialize those shaders here for the render graph because they are fixed shader nodes. So the idea behind the fixed shader node was that the shader is, as the name suggests, fixed. So you cannot change it. So why do I even serialize it? Is like the main question. So I think that's an oversight, but I don't think I can change it now. Mostly because other systems rely on that currently. So yeah, we will leave it for now. Cool. So those are this system, and let's revive the other ones. So lighting system. Let's revive that. And we do an light access. And that would be access. And then we basically read from both of them. Right? And then we do using light, well, yeah, light entity, it's fine, right? Oh, wait, actually, what do we do here? Maybe I want this as a query, actually. Oops. as query. And I do think what I would want to do something like that, right? Where that would be the idea. I think I need another extension there, but then this would be the same thing. So basically we do here, entity here. What is visibility buffers? What do you mean with I mean, where did you see that? Shouldn't you serialize it? Well, I still serialize the node, but not the shader. I still serialize the node itself and the settings of the nodes, but not the rest, basically. Where did you see oh, what did I do? Where did you see visibility buffer? Yeah, I'm not too sure. I need to look at mesh buffers soon. Yeah, we will probably get to that when I do the terrain again. So probably actually next week already. Well, I'm not sure if we will go straight into yeah, mesh buffers, but yeah. So basically I need to go to the entity component system again. And we need to go to the query. Well, actually I want to go down. And here, exactly, something like so how do you is it just that I need to implement a begin and an end for a for-based loop? Never actually, I think, implemented a for each in C++. How do I do that? What does it need? Is there an example of what it needs? Okay. So but I still need some type of iterator, or it needs to return an iterator thing, right? I mean, maybe I have. breath. Okay, then I don't really know. I just want to iterate over the list, but I mean, I guess for now, let's leave it for now. I can do it manually, it doesn't really matter. I will look at that later. Basically, I wanted to do this, but what I can do is get view, and that basically does kind of the same thing. I just need to do an entity. Well, actually, how do I? Yeah, see, that's the problem a little bit. Well, actually, lights access maybe as entity, and I get the entity ID. Oh, well, I need more, right? And the query probably. Yeah, that kind of works. It's like really ugly, but yeah. No, I guess, yeah, you're right. So I guess I could do, oh jeez, view t iterator probably. Maybe. Yeah, but that's not the same thing, right? I mean, not tech, like, yeah, I need a custom iterator. But at least I think that would make it possible to do this probably, right? Yeah. But that's still not the same thing. Because I still need to cast it here, which I don't really like. It's fine, we can live with that for now. Or can I? Yeah, no, I don't know. We will deal with that later. That's fine. This is really the only system where we, I think, need that. And I'm not even sure if I... if I need everything that I do here. The only reason why I do it like that oops. point spotlight is do I even need spotlight index? Wait, how does that? Oh yeah, I incremented here. I don't know. A bit debatable, I guess. But I think that should be fine. Then we do the physics system again, bring that back in. So that one is pretty much just yeah, let's do an access here, I don't know. Read on the transform, and then this will be the interesting thing with init physics. So that one will be the first with here. Now we do using physics entity. Oh, Jesus. Oh, we can do just no, let's do physics entity. See, and that's it. And we don't have an access here. This is just that. Yeah, okay, and then this is again. Oops. Where we copied from up there. So basically we write to the transform, and well, we read the physics body ID. Is that not it? Don't need the full name or what? Okay, I do. And then with dynamic body, right? Because we only want the dynamic bodies. Why would that fail? Oh, because it's probably not. Oh, it's not that. Wait, hold on. Physics, it's components. Okay, perfect. Then let's undo that. Let's do an entity. Well, now that one will be interesting, right? So basically we do want to read the transform, and we need a physics body ID, but I'm not interested in the physics body ID. Or do I need a physics? Actually, maybe not, right? No, actually, yeah. So we read this, or we not read that, but with. And then we do an read if exists sphere collider or box collider, basically. Is that it? I think so. So basically we just read the transform here. And then this is, yeah, that basically. And for now we were still allowed to do it like that, I think. But that should change. And the stream in as well. Oh yeah. The stream in, is it a read or a write? No, it's a read, right? So it's where we read if exists that. That, well, if the with works, then this should work. But yeah, there might be, as we can see, some problems. How did I rename that, right? Or not? What? Point light system. What did I do here? Why would you want to copy constructed? Why, but isn't... Wait, is that fine? Okay, maybe the queries are not working yet. Question is why? But yeah, we basically don't want those. But then, I mean, it shouldn't even call that, right? Because it should already have the query here, and then it's... Wait, was the query maybe passed as a reference? No. Was passed as a... Oh wait, that might have not been... No, it was still like that. Hmm. It's weird. Because isn't that an entity query that's fine here? Yeah, that should be. Totally fine. Entity query. Yeah, but that's fine. I mean, well, actually, maybe it's not fine, you're right. Maybe that's even anyways a problem. Maybe queries should not be allowed to pass as... Because I don't think I want to... that's a good point. Because probably I don't want it to be... Jesus. But then again, would that make a difference? But then how did that work before? Did I before copy the query all the time? Or but technically that should be fine, but yeah. That copy is not too bad. I'm wondering if it wouldn't make sense Or do we have the entity query here? Or okay, yeah, no, we definitely pass it as a ref, yeah? Oh, wait. Wait, which one is that? Oh, okay. I'm wondering. So we built the system call here. Wouldn't it make more sense to just build it here? Like that? Because then it's like never copied. Because we only call it once anyways. Now we go back to our lighting systems. Wherever they are. Oh. And we return that back to copies. Because we get all the entities in like one go, right? And we just iterate over them. That should be fine. Oh, that actually works, okay. Good. So let's see, can we have a collision object again? Okay, yeah, collision stuff works. Can we have the box as well? So I guess my accesses work. We can't really do a light source. Well, I mean, we can do a light source, but I don't know if it works or not. Because, yeah, we don't have anything to see. Yeah, I'm not sure if the... I mean, it gets not really copied now, right? Because, I mean, yeah, it gets optimized. And then the function is the only thing that, yeah, treats it. And we only have like one there. That's fine. I think, did I manage now all systems? No, right? I think I still have a couple of systems that are not new. So this one is new, this one is new, the lighting system, the physics system is... Okay, we need the static mesh and then the volume stuff, okay. And then we are calling it a day for today because I'm super hungry. Okay, so basically that, and then access read, right? We're not doing anything here. Oh no, it's actually a write, never mind. Write to that with a load mesh. I mean, that's already like, I like the new system. It's like so much more clear. You could do all of that in like one, right? You could as well do an S entity there and then have the mesh entity there. But I kind of like separating the access and the basically the access definition and the type of how you access it as a different thing. Because if it's a query or an entity, it's basically how you access the thing more or less. If you get called per entity or like get the whole set of the entities in one go, is basically the thing here. I like how this is called volume entity and then it's not even the volume entity. Okay, so we basically have an access and we do a read on the static mesh and on the transform, and we write, which is actually wrong, but it's fine for now, to the material component. And we don't need any width. Get rid of that. And that's it. System done. I'm not even sure, does it still work? I never tried the static mesh thing again. Rendering material, let's give it the default material, let's give it the sphere. Oh yeah, it works. I mean, it's super small, but there it is. And the default material is like tiling, so that's why it looks like that. It's not a flat color. It's like tiling on the on the UVs more or less, but it is not really smart in how it tiles. But yeah, okay, cool. So that was that. Let's get rid of this. Let's save, and then we have the volume systems as last. And we just restore them, but they are not really working anyways. But yeah, I mean they are working, but probably yeah, we will revisit them now, right, with a change to the volume system. Volume, well, we can still call it just access, right? I kinda think that's fine. Access, and then this is a read, and this is a read, and then we do this, and that is a write. Oops. And then we have using terrain entity, I guess, as access as entity. That's it. And where are our beautiful systems? So let's go up, up, up. Okay, nothing here. Here we have one. read, and then we have a write. To the volume terrain, to the terrain word octree, to the terrain runtime with the init flag. Okay, we have another. Okay, but then we need a name. Camera access. And yeah, it always needs to be a query as the second, and then this one will be a little bit interesting if it actually works. So that one works fine, right? Then the question is, where is the camera query used? Is it even used? Oh yeah, it is. Okay, we get the first one here. Yeah, not idea, but we will deal with that when it's about time. Like, yeah, probably tomorrow also. Well, tomorrow? Yeah, maybe tomorrow actually. I think tomorrow we will start with the terrain again. Well, no, sorry, we need to first do the X11 thing that I kind of forgot again. Beautiful X11 implementation that we need to squeeze in before. Guess. Okay, we need basically the same two queries, it seems like. So the camera entity is as well the same, right? Free camera and transform. So we can get rid of that. And then this is terrain word octree and terrain runtime. So we delete that. We delete that. And we don't. Well, actually, it's a read access, it seems like. Well, no, it's a write, sorry. Because it's not const. Okay. And interesting. What the? Well, okay. Interesting. Alright, whatever. I guess let's see if it just builds. If it builds, I'm fine for now. We will, as I said, come back to the terrain quite soon. And I will probably have to fix a couple of things, because I probably think with all the changes to the entity system and everything, we might have bricked it. What the? Okay, what is your problem? That's probably the entity query, yeah. That most likely is not very happy. Guess the dependent function arc doesn't work. Yeah, because I'm not very consistent. That's why. Yeah, they should have the same name. Oops. I need to go over them and then fix them, basically. Is that what fixes it? Probably not, right? I don't think that will be good enough, but maybe it is. Yeah, no. I'm still too hungry. I thought I would call it a day and we will fix that early tomorrow. But 4 were provided. Okay. Well. I will look at that, as I said, tomorrow. Yeah. Thank you very much for joining, though. We will be back tomorrow with fixing that and then doing a beautiful X11 implementation. And once that's out of the way, we will hopefully have render doc running. And yeah, then with that, there's nothing in our way stopping us from adding physics to the terrain. Have a nice rest of your evening. Take care and see you tomorrow, hopefully. Bye bye.